Today is a great day, and I have the honor and privilege of meeting with Carl Bass.
Robots are smart machines that are starting to do some really incredible things.
From the multi-billion-dollar company, Autodesk. Hey, you must be Carl. Very nice to meet you.
You must be Titan. I've heard some really great things about what you guys do.
Can't do it without the inventor software, the HSM.
Yeah.
Now I hear that you're actually taking the software to a whole nother level. Not only CNC machines, mills, lathes, water jet, all these different things will be like on one platform.
We want all of that just to come from one place, and it doesn't have to be in 10 or 12 different pieces of software.
Yeah, and now you're stepping into 3D printers.
Just last year, we designed and engineered our own 3D printer. We're going to distribute the plans so other people can build the same machine, or they can improve upon the machine.
I think there's probably a day that comes where like kids just all around, like you just have like little 3D printers and they can just grab stuff off the internet and print whatever they want.
Yeah, it gets them excited about making things again.
Exactly. So this must be the 3D printer.
Yeah, so it's a machine. It prints at relatively small but really high resolution, high precision. It prints at tens of microns.
Oh, wow.
Yeah,
wow,
so,
that's like really...
Yeah. You appreciate that.
Yeah, exactly.
Here, so let me show you what we've been doing. So this is the critical thing, you know. A lot of the other stuff is decoration. What really makes this work is that this is a precision part.
So we're talking about making like this piece, this piece, this piece.
Yep.
Okay. We just made a couple fixtures, and these fixtures are gonna go into my horizontal mill, and it's gonna help us run these parts for Autodesk non-stop. So I designed this fixture right here for the first operation. So the first fixture, these pockets I made with T-slots to cut out the corners are perfect for this part. So each one slides in. Then we take this tiny little clamp. It's a Mighty Bite pit bull clamp. And I pop this guy right in on the inside. And we've calculated it perfect so it digs into this edge right here. Because it's plastic, I can actually dig into it and then release it a little bit. And I do one for all 15 pockets. The second op is a little different and it's a little trick. So what we have here is we have another clamp. This guy actually drops down, and as the bolt goes straight down, it spreads, locking one part here, and as soon as the first operation's done, everything's gonna rotate, and this will start machining right here, finishing the parts, and then I'll be unloading the first operation. So this is the second operation. It's gonna rotate, and then we'll just keep doing the same thing over and over, and then we'll just come back after the parts are all done. What a beautiful morning. We are rolling into Eliva, Wisconsin. We're here to check out an awesome school called Eliva Strum. All right, guys, guess what I got for you? The future of American manufacturing. At least it's a piece of the future. I was talking to Carl Bass, who is the CEO of the multi-billion-dollar company Autodesk, and we thought that it would be awesome to give you this MakerBot to take you also into the world of 3D printing. So with a MakerBot, you can actually draw up a solid model, and then you can send it to the MakerBot and print the part in one day.
That's awesome. We appreciate your help, and this just takes us one step further and expands our capabilities, and this is where it's headed, and this is where we want to go.
You guys excited?
Yeah.
Boom!
And these students are amazing too. I mean, they can do anything. You just got to provide the opportunity. You put them in front of these machines, 3D printers, CNC machines, CAD/CAM software. I mean, they pick that stuff up so fast. They grew up with computers. These kids know how to do this.
You give kids hope, you give them opportunity, and they'll go after it. Eliva Strum, right here in Wisconsin, in the great United States of America. Boom! A lot of times when you run parts, you have one part, you go through all the tool changes, so the more parts that you can run at once, you're saving all that time from going and grabbing those tools. In the same setup, you have the second part that assembles to the bigger one, and that gets run over here. You got 4 of these, and they flip over into the special cut soft jaws right here. 16 parts, 2 different jobs coming out at the same time, complete, so we can make sure everything fits, form and function is perfect. here we go, Tyson. Pier 9, Autodesk.
Now what goes on here, first of all, is building software that helps make stuff. And so we built this so that we could test all of our software. And I think it's great to return people back to the machine shop and have people get hands-on and get them dirty and have them make stuff.
I love it.
So I'm sure you know this machine.
Oh yeah, it's a water jet.
Yeah, 50,000 PSI approximately.
Does your software program the water jet also?
Yeah, absolutely. A couple of years ago, we made the decision to give away our software to every school, faculty member, and student in the world. That's something that we could give back in training the next generation of designers and engineers and machinists.
That's amazing.
Let's move on and look at a couple of the other machines. Looks like we caught Daniel working on his robot.
Yeah,
Doing robots.
yeah, you know it.
So you designed this yourself?
Yep. So I used Inventor to design the robot as well as to machine it out.
That's kind of the point of Pier 9. We're trying to push the boundaries of what's possible. And then, Daniel does some amazing stuff on our Instructables website.
Yeah.
Part of our mission is to make sure we spread the word.
Yeah.
So we can pass it on to more people.
Hey, by the way, Titan, that robot arm I showed you is right around the corner. Let's check it out. So, as I was mentioning earlier, all machined on the Haas, right? And this is basically 2 rectangular extrusions flipped around on all different sides.
So do you pay Autodesk to let you come here and like play?
I just say thanks, Carl, for building this shop.
Yeah,
Exactly.
that's awesome.
So this is the 3D print shop. These printers can print out of multiple materials. So this one I find really interesting in that it's 2 materials.
Yeah, it's like really soft and
that
then really
one?
hard.
Yeah, there's lots of new materials. So people are printing in plastics,
Yeah.
people are printing in metals,
Yeah.
and they've even started to 3D print organs. There's been a 3D printed bladder, which people have grown in, it's been implanted. I mean, this is a huge breakthrough in medicine that's coming about. And so remember in the shop I was telling you about this new technology we have in which you describe what you want the computer to do and it creates
And
the parts
the
for you.
software designed its own
Yeah, the software
part.
designs it, and I showed it to you. So here is a 3D metal print of that heat exchanger.
Wow. I actually could CNC machine this.
Oh, really?
No. he was gonna call me out on that one. That's amazing.
Now, the part that I think is going to get really interesting in the next few years is this combination of doing CNC machining and doing additive manufacturing, in which they have interchangeable heads.
Building it up and then the mill comes down and machines it.
You'll be able to get kind of the shape complexity from 3D printing, but you'll get that surface finish and precision that comes with CNC machining. So let me introduce you to Shalom. He's busy assembling the parts.
I hear you are the man.
Well, I got the parts right here. So I
Making it
design
happen.
right now.
How did it look?
Yeah, looks great, actually. Just putting them together to test that we've got a great fit.
Must have had some great designers and assemblers and
I'll say, whoever designed and built this knew what they were doing. We're good to go here.
that's awesome.
Yeah, man. Here, I'll just throw them together right here. Everything meets really perfectly as required. It makes a perfect fit.
So it fits, huh?
Ah, no, man, this sucks. The parts don't fit.
I just watched it. I just watched it. It looks like perfection to me.
No, man, it's
Look at
totally
that.
perfect. Love it. All the parts fit together perfectly. It's ready to install on Ember's Z-axis. We've got to have everything be super precise here because we're 3D printing down to 25 micron layers. Even we could go down to 10.
So 25 microns, like we deal with 0.001 1,000ths.
Sure.
So we have a 3D printer and we're about plus or minus 5,000ths as far as our tolerance goes.
We're well
20%
below
that,
Yeah,
right?
yeah, we're well below that. And
Awesome.
we can go even further down to 10 microns, or that would be a fraction of a thou.
Very, very fine.
Very fine. Yeah, that's the
Awesome.
best I can put it. Yep. Snug the calibration bolt. Close this up. Safety first.
3D printing is so amazing to me. I thought there was like maybe 1 or 2 styles, so this is a whole nother style, completely different than anything I've ever seen.
So with this, we're actually printing with UV light and photosensitive resin. You see the light under there? UV light shining through. You can see the blue glow. That's actually transforming the liquid resin on that layer into a solid. So professional users like jewelers and dentists really love this machine because it enables them to print with incredibly fine detail that wasn't really affordable at this price point. So we're really excited about what we're creating and also about putting it out in the wild and seeing what other people are going to do as well.
Well, thank you very much for having us. What an amazing experience.
Hey, it was a pleasure showing you guys around. I wasn't sure when we gave you that challenge you were going to be able to pull it off.
Well, the parts weren't really difficult, but it's making them in just a minute so you can keep the price down. I think we showed that we can do it right here in America.
We look forward to continuing to work together. Okay,
All right, Carl.
Okay, take care,
Thanks,
guys.
sir.
Nice to see you.
Take care, Tyson. Well, this was incredible. Less than 2 weeks to turn around those parts. I mean, it's great to see jobs coming back to the U.S. in manufacturing. We've given our software away free to the schools. We love seeing what middle schools, high schools, colleges are doing to bring back manufacturing to the United States.
What a world we have. American manufacturing, it just takes you to incredible places.
Everything I saw here was incredible. Like, I can't believe that stuff like this is happening down in San Francisco. So people just come here to make whatever they can think of off the top of their heads. Like, they get paid to invent stuff.
Yeah, it's amazing. I used to come to this city when I was like 19 years old with my 6-month-old baby boy. Now 25 years later, we're hanging out at the great Autodesk, and they create the software, the brains, so we can produce on a high level. We're proving that American manufacturing is not dead, it's alive and well. And this TV series is pulling back the curtains to show you all this greatness. It's called Titan, American Build. Boom.